The mathematical model representing the expected total energy generation. This part is to explain the mathematical model of biomass power generation. To find the biomass efficient transfer, first we need the value of the biomass in higher tropical level divided with the value of biomass in lower tropical level. If we times with 100, we can manage to find the percentage efficient transfer. 1 million of agriculture waste is used to generate 2.5 megawatt of electricity in a biomass power plant. It's enough to power approximately 2,600 home, where it's equivalent to the one whole town. In Malaysia, Malaysia can produce more than 2,400 megawatt of biomass and 410 megawatt of the biogas potentially. Rice husk is another important agriculture biomass resources in Malaysia. An example of the attraction energy potentially in biomass power plant is in the state of Perlis, which use rice husk as the main source of fuel and generate 10 megawatt power to meet the requirement of 30,000 households. There are many techniques through which biomass can be converted to the power, such as combustion, pyrolysis, gasification, aerobic decomposition. At the end of this method, different type of fuel substance will be produced, and the fuel is used in steam turbine to produce electricity energy. Steam generation control system. This formula is used to find saturated water or steam property. Fs equals to Xm plus Knp. Fp is referred to the saturated water or steam property. Xm is constant of equation plus with the derivation of saturated water divided by the steam pressure. Turbine and generator. If we see this is the block diagram of the turbine control system. First, there's a comparator. Comparator will send the speed sensor to the servo motor, which there is another name which we call PIC controller. Then the signal will send to the steam valve system. The steam valve system will decide how the clockwise or anti-clockwise and how the rotation of the valve will open once the steam enter. This steam will use to turn the turbine rotate. Moreover, there's a control system which will send sensor to the speed sensor. Speed sensor will determine how speed it will be used. Speed signal will send to the comparator. Later on, we will see about the servo controller formula and the steam valve system and how it operate and how the calculation. Okay, for the PIC controller equation, we have the formula how it work. Du over dt equals to Gp. Gp is referred to gain factor of the PIC controller times with the differential of turbine speed over dt plus turbine speed minus turbine speed not divided by the time constant of the controller element. Okay, we look for the steam valve equation. This is the second derivation order. First, we should derive the steam valve coefficient in the second order, then plus with 2 natural frequency of the steam valve system with first order derivation plus with the natural frequency of the steam valve system power 2 bracket with steam valve coefficient minus with steam valve coefficient not, and the answer of this formula will be out with GB natural frequency of the steam valve power 2 with U. Now we look on the turbine power equation. PT equals to steam valve coefficient times with steam pressure of steam generator times with overall enthalpy drop in the turbine. This formula will help to find the turbine output power.